Hey guys, so this video is about adding, subtracting with radicals. So kind of got two styles of problems in this section. One, no fractions, something like this, and then one coming up with a few fractions in it. So the deal with radicals is it's kind of like you have to add like terms. So everything has to be the same under the radical for you to add stuff or subtract. So for instance, just like if I had 3 root 7 plus 2 root 7. That's just like saying I have 3 of these plus 2 of these, and that makes 5 root 7s. So a good way to think of these is if it works with an x, it works with a radical. They basically kind of work the same way. So 3x's plus 2x's makes 5x's. And you'll see the radicals kind of do the same thing. So you're adding the numbers in front, but these have to be the same deal. So if I had 3 root 7 plus 2 root 5, that would be like 3x plus 2y. Can't put them together. And so what's going to happen is we're going to get these expressions that we're supposed to add or subtract, but then nothing will be like. And so what we have to do is simplify like we did in the last section, all these radicals, so that then we can figure out what our like terms are and get them combined. So with this, I'm going to rewrite this kind of showing my squares and then pull everything out. So this is going to look like 4, and then 8 is going to be a 4 times a 2. And so I can see I'm going to have a 2 left over. So that makes me look for 2's in the rest of these. So this is going to be 2. 2 goes into 50 25 times, so that'll be 25 times 2. And then minus 5. 2 goes into 72 36 times, so that's going to be 36 times 2. So right here, 4 times square root 4 makes 2 square root 2. Here, square root 25 makes a 5 come out, 2 still inside. Right here I got 5, square root 36 would be times 6, and then root 2. So then I can multiply these together, and I'm kind of showing this extra step in here because a really common error is for people to go like say on this one, square root 25 is 5 plus 2 is 7 instead of 2 times 5 makes 10. So I'm just kind of trying to show that hey, each of these are multiplying and kind of how all the pieces are going together. So right here we got 4 times 2 for 8 root 2. 2 times 5 for 10 root 2's, and here for 30 root 2's. And so this is just like 8 minus 10 minus 30 of some things. 8 minus 10 would be minus 2 of them, minus another 30 would be minus 32, and they happen to be root 2's. And because these are all the same, I can add and subtract them. If they're different roots, couldn't do that. So these next couple I would have you guys try. So this would be 2, and then 27 I'll write as 9 times 3, plus 2, 147, that one is 49 times 3. And like if you don't see the 49, I mean that's easy enough to not see the 49. Once you got the 3 back here, it makes you go 3 goes into 147, 49 times. 3 goes into 75, 25 times. So once you kind of figure out what's going to be left behind, you can figure, I mean, they don't have to, but that's the kind of the idea of the section is you're going to be able to collect terms, so very likely they will be the same thing. So this one will be 25 times 3. And then I'll take the stuff out. So 2, I'm just going to write this extra step just to try to show where the pieces go. So 9 comes out of 3, plus 2 times square root 49 would be a 7 root 3, minus square root 25 would be a 5 root 3, and then just tidying those up I got 6 root 3 plus 14 root 3 minus 5 root 3. So that's 20 root 3's minus 5 root 3's, I think we get 15 root 3's. And then this next one, this would be, let's see, 40, 20, and 45. So the easiest one to probably see is the 20, and that's going to be a 4 times a 5 in there, and it kind of lets you know there's going to be a 5 left over everywhere. So this would be, just going to do that, 4 and then 16 times 5 minus 4 times 5 minus 5 times, and then 45 would be 9 times 5. So you can kind of see we have these leftover 5s. So bringing the 16 out, maybe I'll do this all at once in this one. 4 times 4 would be 16 root 5. And that's because this is a 4 coming out, and 4 times that 4 makes 16. Minus 2 root 5. Square root 4 is 2. This comes out of 3. 3 times 5 would be minus 15 root 5. And just as I'm doing that, I think probably it's better to write yourself that little step, but I just see a lot of people make errors right in there. So anyhow, so this is 16 minus basically 17, so that's like a minus. We wouldn't write it this way, but you can think of it as minus 1 root 5, but the same way we wouldn't write minus 1x, this we would really think of it as just negative root 5. But this invisible one can really kind of mess with you, so that's just a good way of thinking what's happening there with the 16 minus 17. So these two are fairly similar. There's just kind of more letters going on. So this one, we have 7xy out front, and then cube root of 8, so that's going to bring out a 2. Cube root of x cubed, that's going to bring out an x. And then cube root y squared I can't do, so that will just stay inside. And then here this is going to go 4 times cube root x to the 6, so 3 goes into 6, x squared comes out, 3 goes into y to the 5th, a y comes out, and 2 y's are left inside, because 3 goes into 5 once with 2 left over. And if I clean up this little bit, I got kind of numbers and x's everywhere, so we'll make this 14x squared y, and then cube root y minus 4x squared y cube root y. Oops, that y should be squared, sorry. And so you can see everything is the same. X squared y, cube root y squared. Same thing over here. So since they're like terms, I can go 14 minus 4, and that leaves me 10 of those things. So x squared y, cube root y squared. This one, pretty similar, a little less on the exponents, a little more on the numbers. But this would go 7, and then I'm just going to write this as, actually I'm just going to write it right underneath. So another thing I'll do sometimes is I'll just jot down underneath. This one is going to be 4 times 3. The 27, that's going to be 9 times 3. And then 108, that's going to be 36 times 3. And I'll just sort of do that as my visual for what I'm pulling out, what's staying inside. So sort of ignore that big old wad of nothing. So now I'll bring down my 7, and then square root 4 is going to bring out a 2, and then I got an x cubed in there, so 1x is going to come out, and then I'm going to have a 3x left on the inside. And then here I get minus 4x times 3, and a 3x on the inside. Here I'm going to get plus, so this is 36 on the inside, so it comes out of 6x, and then 3x. Cleaning this up so we can see what's there a little bit better. 14x, radical 3x minus 12x root 3x plus 6x root 3x. And again, all of our stuff, like terms, that means we can collect it. So 14 minus 12 would be 2, plus 6 would make 8x, and then 3 under 8, sorry. 8x square root 3x. Let's see, for 6 through 8, those ones would be to you guys. Grab the next page. Okay, so for number 6, we'd have a 2, 3 goes into 8 twice, and there'll be 2 left over, and then 3 goes into 6 twice with none left over. So there'll be a cube root of x squared underneath. and then 3y squared. Cube root 8 makes it 2, and then 3 goes into 8 twice with cube root x squared left underneath. So then kind of cleaning this up, this one doesn't really clean up over here too much. It is what it is. And then that's going to be minus 6, and then x squared y squared. So it's good to write it alphabetical so you can see your like terms a little bit easier. Cube root x squared. And then 2 minus 6 would be negative 4. And then of these, so x squared, y squared, cube root x squared. For number 7, so the easiest of the numbers I think is probably the 24 to see. There's a 4 times 6 going on in there. And once you see it's going to be a 6 left over, then here you go, 6 goes into 54. Okay, that one's going to be 9 times 6. And then for 216, that I believe is 36 times 6. That'd be 6, yep. And so then once you kind of see the first 6, it does help you out with the harder numbers. So down here I'll have a 2a, and then square root 9 is going to bring out a 3, root 6. Here I'll have minus 3, and then there's going to be a 4 under there, so that's going to be a 2 plus that a, root 6. And here we'd have minus 6a, root 6. And putting this stuff together, I get 6a root 6 minus 6a root 6 minus 6a root 6 again. So 2 of those cancel, and then the leftover negative 6a root 6 would be it. And then this one would also be to you guys. Here I think the 50 is the easiest one to spot. That would have to be a 25 and a 2. So once you kind of know that it's 2's left over, then you go 2 into 32, and that helps you see the 16 times 2. And then 2 into 128 would be 64 times 2. So you can kind of see once you get pick the easiest number, do that one first, and use that to kind of check the others and see if that's where it's going to go. Because often that's where it's going to go. So here we have a 5a. Square root of 16 would bring out a 4, root 2 left behind. Minus 3, 25 brings out a 5, and then a squared brings out an a with a 2 left behind. And then minus square root 64 would make an 8, a, and then root 2. So let's see, we got 5 times 4 is 20a square root 2 minus 15a square root 2, and then minus 8a square root 2. So 20 minus 15 would be 5, and then minus 8 would make negative 3a root 2. Okay, and then we have the ones with the fractions. Just to remind us of the steps. So first, for me, I like to do this as 2 steps. It is possible to do it as 1, but it's pretty hard to see, especially if you're new to these. So I would do step 1, rationalize the denominator, and then step 2, separate step, get your common denominator. So first, just kind of clean it up so you can see what you got, and then deal with making them the same. And then once you have a common denominator, then you're just combining your numerators, because now you can add and subtract. So that's kind of our plan for these. So for this first one, I'll just rewrite it down here so you can see it a little bit better. For my first step, I'm just going to do root 6. So I'm just going to rationalize any radicals in the denominators that need rationalizing. And then in this case, that pretty much gets it done for the common denominator, because root 6 makes 6 plus root 6 over 6. So these have a common denominator now, so I can add them. People are often really confused by what that would look like, and I think it helps to think of the invisible one right there. So just the same way that like the first time you saw that x plus x, that freaked you out, and now you've kind of come to grips with the fact that's 2x. So square root 6 makes 2 square root 6's, the same way this makes 2x. So we get 2 root 6, or invisible 1 plus invisible 1 makes visible 2. And then here, this cancels just like any other fraction, because that's multiply. So as long as things are multiplying, then I can cancel. And the other thing is they're both, you know, this is under a radical, so I can't work with this, but these are both not under the radical, so I can cancel. So then just reducing that, 2 goes into 2 once, 2 goes into 6 3 times. So that will be square root 6 over 3. On this one, let me rewrite this over here. So root 30 minus 10 root 3. And then I'm going to throw a root 3 right in here, because I'm going to just take care of these denominators first. And then that'll be plus 3 over 10. And that's going to be root 10 over 10. And this can kind of help since we got fractions coming up to think of it as over 1. So we'll just do our 30 over 1. This will be 10 times 3, so that's 30 over 3. And then this will be 30 over square root, or it would have been root 100, so then just plain 10, because root 10 times root 10 is 10. So then for my second step, now I'll get common denominators. So here I just have, I have 3's and 10s, so my LCD is going to be 30. So right here I need to multiply by 30 over 30. Right here I need to multiply by 10 over 10, because I have a 3, so I need to bring it up to 30. And then right here, I didn't space that very well, I need to bring 10 up to 30, so that's going to be a 3 over 3. So now you can see everything's over 30, so that gives me 30 root 30s minus 10 root 30s plus 3 root 30s all over 30. And so 30 minus 10 would be 20, plus 3 is 23. Root 30s over 30. Okay, these last couple would be to you. So here, 1 square root 5 plus root 5 over 2. So first thing I'll do is just root 5 right here. So then that's going to get me a square root 5 over 5 plus square root 5 over 2. And so now I can see, okay, I got 5's and 2's. So this side's going to need 2's. This side's going to need 5's. And that will make both of these 10's down below. So then that gives me 2 square root 5 plus 5 square root 5 over 10, or 7 root 5 over 10. And 7/10 doesn't reduce, so that would be it. For this one, so a couple of things going on. So 45, they're being sneaky. That's a 9 times 5. So we can bring that 3 out of there. And that's going to be 3 and then square root 5 over 10. Here, I have this 1/5. So I'm going to go ahead and rationalize that. And then this is kind of coming along. So now this is going to be 3 root 5 over 10 minus root 5 over 5, because that's root 5 makes 5, and then plus 6 root 5 over 5. So you can see we got 10's and 5's, so that means I need to bring these ones up to 10. So that's going to be 2 over 2 times, and then 2 over 2 right there. So that gets us 3 root 5 minus 2 root 5 plus 12 root 5's. And then these are all over 10, so it's legit for me to put all over one denominator. So 3 minus 2 leave me 1, and then plus 12 will give us 13 root 5s over 10.